In episode 76, titled Documentation Essentials, Data Dictionary, Metadata, and Change Tracking, the goal is to document work so models remain usable, auditable, and repeatable, because the value of a model is not just in its accuracy, but in its ability to be maintained and defended over time. The exam cares because documentation is governance in practice, and many scenario questions reward the candidate who understands that technical work without traceability is operational risk. In real systems, documentation prevents models from becoming mysterious artifacts that only one person can operate, and it protects teams when questions arise about why a decision was made or why performance changed. Good documentation also accelerates iteration because it turns past experiments into reusable knowledge rather than forgotten effort. The key mindset is that documentation is part of the model, not a separate administrative task. If you build documentation as you build the pipeline, you create systems that can survive handoffs, audits, drift, and organizational change. Before we continue, a quick note. This audio course is a companion to the DataX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A data dictionary is the first foundation because it describes fields, types, units, and meaning in a way that makes the data set understandable and reusable. Each field should have a clear name, a type, such as categorical, ordinal, continuous, discrete, or binary, and a unit where applicable, because unit ambiguity is one of the most common sources of silent error. Meaning should be described in operational terms, such as what the field represents in the system and how it is generated, not only in technical terms like string or integer. The dictionary should also include allowable values for categories, expected ranges for numeric values, and notes about missingness meaning, such as whether missing indicates unknown or true absence. The exam cares because a data dictionary prevents misinterpretation that can lead to incorrect summaries, wrong encodings, and leakage, and it enables new analysts to use the data without guessing. A strong dictionary does not just list columns, it explains them, and that explanation is what makes the data safe to use. Metadata makes the data dictionary operational because it captures source, collection time, refresh cadence, and ownership, which are the properties that determine reliability and maintenance responsibilities. Source tells you which system or service produced the field, which matters because source systems change and because different sources have different trust levels. Collection time tells you when the data is captured relative to the event of interest, which matters for leakage prevention and for understanding timeliness at inference. Refresh cadence tells you how often the data updates, which matters for drift detection and for whether a feature is usable in real-time workflows. Ownership tells you who maintains the source and who can answer questions or approve changes, which is essential in operational environments. The exam expects you to include these because analytics is a supply chain, and metadata is how you manage the supply chain. When you capture metadata, you make dependencies explicit rather than implicit. Version tracking is how documentation stays truthful over time because data, code, features, and model artifacts evolve, and without versioning, you cannot reproduce results or explain changes. Data versioning means you can identify the exact dataset snapshot used for training and evaluation, including time range and extraction logic. Code versioning means you can identify the exact pipeline and model code used, which matters because small code changes can alter preprocessing and feature computation. Feature versioning means you can identify which derived features exist, their definitions, and their parameters, because derived features are not raw facts. Model artifact versioning means you can identify the trained model, the preprocessing objects, and any configuration files used for inference because these artifacts define behavior in production. The exam cares because versioning supports auditability and rollback, which are essential for governance and reliability. When version tracking is done well, you can answer what changed and why without guessing. Assumptions, exclusions, transformations, and imputation rules must be recorded clearly because these choices shape the dataset and the model's behavior, and they often determine whether results are valid. Assumptions include the unit of analysis, the time window definitions, and the availability of features at decision time, because those assumptions determine whether evaluation matches deployment. Exclusions include filtered records, removed outliers, and segment restrictions, because exclusions change the population the model applies to and can create bias if not justified. Transformations include logs, power transforms, scaling, and binning, because transforms change meaning and interpretation and must be applied consistently at inference. Imputation rules include how missing values are filled, when missing indicators are added, and what constitutes unknown versus zero, because these decisions affect both performance and fairness. The exam expects you to make these concrete rather than vague, because cleaned data is not a reproducible statement. When you record these rules, you make the pipeline deterministic and auditable. Known limitations, bias risks, and expected failure conditions should be documented explicitly because they define the boundaries of safe use. Limitations can include label noise, missing coverage in certain segments, measurement inconsistencies, and uncertainty about causal interpretation. Bias risks can include proxy variables, segment performance gaps, and systematic missingness that affect certain populations more than others. Expected failure conditions include drift scenarios, such as new categories appearing, policy changes altering behavior, or adversarial adaptation, and they should be stated so monitoring can target them. The exam cares because responsible model use requires knowing when not to trust the model, and documentation is how you preserve that knowledge when teams change. Documenting risks also supports stakeholder trust because it shows you are not hiding weaknesses. When you capture failure conditions, you create a plan for managing reality rather than pretending the model is universally correct. A practical exercise is writing a 1-minute model summary for non-technical stakeholders, because this is the kind of communication that turns documentation into action. A 1-minute summary should state the problem, the model's purpose, and what the output is used for, such as prioritization, forecasting, or decision gating. It should state the primary metric and what it means operationally, such as fewer false alarms at the same capacity or lower typical error in forecasts. It should state the main limitations and what safeguards exist, such as monitoring, guardrails, and rollback plans, without drowning the listener in technical detail. The exam expects you to produce a summary that is accurate, cautious, and decision-oriented, because that is how models are governed and adopted. When you can do this, you show that documentation is not just for engineers, it is for decisions. Vague documentation is a common failure, and the exam often tests whether you avoid it by including concrete thresholds and definitions. Instead of saying, "we removed outliers," you should record what threshold defines an outlier and why that threshold was chosen. Instead of saying, "we imputed missing values," you should record which method, what values, and whether missing indicators were added. Instead of saying, "we used time-based splits," you should record exact time ranges for training, validation, and test, and the rationale for the cutoff.
Concrete definitions make documentation actionable and auditable because they allow someone else to reproduce the dataset and model behavior exactly. Vague statements also undermine trust because they create the perception that the pipeline is subjective or changeable at will. When you insist on concrete thresholds and definitions, you create documentation that can survive audits and handoffs.
Reproducibility depends on recording parameters, seeds, and split logic, because these are the details that ensure a rerun produces the same results and that the comparison across experiments is meaningful. Parameters include hyperparameters, regularization settings, feature engineering window sizes, bin boundaries, and any tuning choices that affect model behavior. Seeds include random initialization seeds and split seeds because random processes can produce different results if not controlled. Split logic includes exactly how splits were created, including stratification rules, grouping rules, and time cutoffs, because split differences can produce large performance differences even with the same model. The exam expects you to treat these as documentation essentials, not as optional details, because without them you cannot defend claims like "this change improved performance." Recording these details also supports debugging, because when performance drops, you can determine whether it is due to drift or due to an unintentional change in pipeline configuration. When you capture these elements, you turn your work into a repeatable process rather than a one-off run. Governance requirements often demand logging approvals, reviews, and policy constraints because models operate within organizational rules, legal requirements, and risk tolerance decisions that must be traceable. Approvals can include privacy reviews, security reviews, and business owner sign-off because these establish that the model is authorized for use. Reviews can include fairness assessments, risk assessments, and validation reviews because these document that the model was evaluated beyond accuracy. Policy constraints can include restrictions on certain features, limitations on where the model can be used, and required human-in-the-loop steps because these constraints shape deployment. The exam expects you to recognize that governance is not informal. It is a documented set of decisions that constrain the model's lifecycle. Logging these items also protects the organization because it shows that decisions were made deliberately and with appropriate oversight. When you include governance logs, you integrate technical documentation with organizational accountability. A monitoring plan should be documented because models degrade without monitoring, and monitoring is part of the model's life cycle. The plan should include which metrics are tracked, such as precision at capacity, calibration, and segment disparities, because these indicate whether performance remains acceptable. It should include drift signals, such as shifts in key feature distributions, rising missingness, or new category appearance, because these are early warnings of change. It should include retraining triggers, defined as thresholds tied to business tolerance, because triggers translate monitoring into action. The exam expects you to include this because deployment without monitoring is unmanaged risk, and documentation without monitoring is incomplete. A documented monitoring plan also clarifies responsibilities, such as who receives alerts and who decides on retraining or rollback. When you document monitoring, you show that you understand models as maintained systems, not as static reports. Change logs should be short and useful, capturing what changed, why it changed, and what impact it had, because long change logs are rarely read and quickly become stale. The what should state the specific change, such as adding a feature group, changing an imputation rule, or updating a data source version. The why should state the motivation, such as addressing a residual bias, reducing leakage risk, or improving stability in a segment. The impact should state what happened to performance, calibration, and operational metrics, including any trade-offs, because changes rarely improve everything at once. The exam expects you to keep change tracking concrete and outcome-oriented because change logs exist to support accountability and learning. Short, precise change notes also support rollback decisions because you can identify which change introduced a regression. When you keep change logs disciplined, you make iteration history usable rather than overwhelming. A helpful anchor memory is, if it is not written, it did not happen. This anchor is strict for a reason, because undocumented decisions cannot be audited, cannot be reproduced, and cannot be defended when questioned. Writing things down is what turns individual knowledge into organizational knowledge, and organizations depend on that when people rotate, systems evolve, and regulators ask for evidence. The exam rewards this mindset because it aligns with governance, professionalism, and reliability in applied analytics. It also prevents the common failure where models become unmaintainable because key choices exist only in one person's head. When you internalize this anchor, documentation becomes part of doing the work, not a task done after the work. To conclude episode 76, draft one data dictionary entry and then one change note, because this demonstrates that you can be concrete and operational. A data dictionary entry might be for a field called session latency MS, described as a continuous numeric measurement in milliseconds representing end-to-end response latency for a user session, with expected range from 0 to a high bound based on system design, and with missingness indicating telemetry not captured rather than true zero latency. It would note whether the value is recorded at session end, which matters for leakage and timeliness, and it would state the source system and refresh cadence so users know when it updates and who owns it. A change note might state that a log transform was added to session latency MS to reduce write skew and stabilize variance after residual analysis showed increasing error spread at high latencies, and that this change improved held-out calibration and reduced large error frequency while slightly reducing interpretability for raw unit shifts. It would include the exact transform and parameter handling for zeros, and it would reference the model version and evaluation period used to measure the impact. This is the standard the exam is testing: concrete definitions, clear rationale, and traceable impacts that make your work repeatable and auditable. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.